Yes, let's get started with CAD activity lab A2A. It says look at the values that I have calculated in the lecture using K1 and KCL rules, and of course and node method. These are the values. E1 is, yes, look, this is the circuit, and applying node equation method, I have calculated that the E1, the node voltage E1 is 4.15 and E2 is 4.85 volts. And it says draw the circuit using CAD program multisim and observe the node voltages. Compare them with lecture notes. Yes, let's draw the circuits. First, I'm clicking on place source. I need a source, DC power. I'm clicking OK. I put the DC power and I need a ground here. I click OK. That's it. And I should change the group. It should be basic because resistors are here. I need a 1.5 kilo ohm resistor. I put it here. Then I need a 3.9 kilo ohm resistor. It's here. Look. Okay. It should be here and once more here. Then I need an 8.2 kilo ohm resistor. One is here and the other is here and close. Then I should rearrange the components. I should rotate them. I am clicking on the right button on the component, and I can change the rotation of the components. I am rearranging them. I can carry the components while on the component I click on the right, on the left button of the mouse, and I don't release to carry. When I release, it releases the components. Okay. Now I have to connect. Okay, look, this is 12. I have to change it to 9 volts because I have a 9 volt battery. Now I have to connect the components. Let me connect the components. As you see, it automatically draws a wire line. You click some point, it automatically draws the line. So if you fix the line, you have to click on some point, for example like this. It automatically changes the wire connection. But if I click on some point, it does not change the before portion. And I have connected the positive terminal of the voltage source to a terminal of this resistor, and I will connect the other component. I will connect other one, this one, okay, connect here. That's it. This is ground. Let me connect it here. Okay, I have completed my circuit, but I need some multimeter, voltmeter to measure the node voltages. This is a multimeter. To measure a node voltage, the reference point is accepted as the ground. So I have to connect the negative terminal to the ground. It's grounded, and the positive terminal to the node. So I will measure the voltage of this node, and I need another one. Put here. Negative side should be grounded because I am measuring the node voltage, and the positive side should be connected to E1. Okay, this is showing E1, this is showing E2. I started the simulation. When I click on these measurement devices, I can see the voltage of these 2 points. Let's look at the theoretical results again. Okay. It says E2 is 4.85 volts. And E1 is 4.15 volts. So let's look at. Yes, it says the voltage of this point is 4.146. In theoretical calculations, we have approximately found 4.15. So it's correct. And the voltage of E2 is, in theoretical calculations, we have calculated 4.85, and it's 4.85 approximately. So there is no problem. Okay. Simulation and theoretical calculations are the same. Then, what are the next steps? It says measure the voltage of a loop and the currents through a node by the program and confirm KVL and KCL. So I can delete these guys, click on this and click the delete button. This is my circuit. I will measure the voltages. I am selecting all of them and carry all components to here. I will measure the voltages of this loop. I need 3 multimeters. One of them is here, the other is here, and the other is here. This will measure the voltage of voltage source. This will measure. Look, I am starting from this point and I am drawing a path like this. And always I have to use the same polarities. For example, here I first see the negative side, so here I should connect the negative side first, like this, and again I have to do the same thing. So there are 3 different voltages. Current is in this direction. I am assuming this side is positive, this side is positive. So of course some of them should be negative and summation should be 0 because of KVL. Let's look at the results. It says 9 volts. Second says minus 4.85. The third one says minus 4.15 approximately. So summation of these 3, 9 plus minus 4.85 plus minus 4.15 is approximately 0. Not approximately, it is just 0. So there is no problem, it's okay. This part is okay too. I'm closing the simulation. I am deleting these multimeters. I have applied the KVL. I have measured the voltages of a loop and I have seen that KVL is okay. And for one node I will apply KCL. For example, for this node I will apply KCL. Again I need 3 multimeters, but now I will measure the entering currents. So if the currents are entering, this side should be positive, this side should be negative. This is the current entering from this node, and the multimeter should be inserted like this if it is used as a ammeter. Okay, if it was a multimeter, I have to connect the multimeter like this. It's a parallel connection, it's a multimeter. I am deleting it, but now I will use it as an ammeter, so I have to connect it in this manner, in series. So the second ammeter, The current is coming like this, and the third one, another multimeter. The current is coming like this and like this. So first current, second current, the third current, all of them are entering to the node, so summation should be 0. Let's simulate. First current, second current, and the third current. I have to click on A to see the current. If you click on V, you will see the voltage. If you click on ohm symbol, you will see the total resistance of those points. So look, this current is, the entering current from here is 1.062. This is minus 170. This is minus 590. The summation of these two is approximately this. So summation of these three will be 0. So KCL holds, no problem. Okay, I'm closing. So you have to be able to do this. You have to be able to measure the voltage of a component. You have to be able to measure the current of a component, and you have to save this file on desktop. Write your course, write your section, for example 1 or 2, whatever you want, and write your name. For example, my name is Muhammed Ali ERBİR, and save this file. Close the program, and as you see, this is my multisim file, and send this file to your teaching assistant, lab assistant. Like this. For example, my lab assistant is someone at atılım edu.tr. Hi sir, attachment is my CAD activity for week something. Name, write your name, surname, student ID, course E134, and send your email. That's it. Thanks.